Hi, welcome to this week's video. We're going to be covering the new function within Excel 365 and Excel 2019. These are dynamic arrays. They're going to change the way you write your formulas. No more writing static, single formulas in every cell. We can write simple, dynamic arrays that spill over multiple columns and rows, all from one single formula. That means you're going to go from writing formulas like this to create cumulative totals to formulas like this. One single formula spilling your array. Let's take a look at how we do it. So to illustrate a simple dynamic array, I'm purely going to reference this set of data that I've got. No functions, just a simple cell reference. If we commit that, you can see now this behavior here, where we've got a duplicate of this, just using one single cell, is called spill. So this dynamic array formula is spilling the results of this range. If we click in any of these other cells, you can see the formula goes slightly grey, and that means there's no editing that can be done here, as this isn't the source of this dynamic spilled array. If I was to press delete here, you can see the data just instantly returns because there is no actual real content there. And if I was to type there, you can see we get this spill error. What that's telling us is there's a dynamic spill array, which has been outlined by these blue dashes, cannot properly spill because there's already contents within the cells. If I delete that, you can see we can spill again. The way these dynamic spill array functions work is it's a single cell which calculates and then spills over a range. Now this is all held in memory and is one single formula. So if you compare this to static formulas, like we traditionally are used to writing in Excel, this is a lot more efficient for Excel to actually calculate, and it's also more efficient for the user to be able to just update one single formula instead of looking through numerous formulas for the same outcome. Let's demonstrate that here. So if we were to achieve the same results using traditional static formulas, we'd put A3 here, we'd copy it down the number of rows and across the number of columns. So now, in this simple 21 row grid by 8 columns, we have 168 formulas to maintain, and Excel has 168 formulas to calculate. Now you can see why that's harder for Excel to run and also harder for us to maintain in the future. This new method of writing formulas with dynamic arrays mean we can write single cell formulas that spill over massive ranges, and at the end of it, we just need to maintain that one cell. So much easier to audit and make sure that your spreadsheet is working as intended. Imagine someone came along, decided they didn't like this particular result or it was wrong, and instead of updating the actual data, they just typed 20 in there. The next person comes along to open the spreadsheet, they see the formula here, go over a couple of rows, yeah, I can see what this formula is doing, it's just a copy of this. What they don't realise is buried within here is one static cell reference. Whereas with this new spilled array, they're looking at one cell, they can instantly see exactly what's going on, far easier to control. Note these dynamic arrays are live results of whatever they're calculating. For example, if I was to change Arsenal to Ben FC here, keep an eye on the right hand side, you can see we have instant spill results of the live data. Now we're going to have a look at a wide selection of the functions you can use to work with your dynamic arrays. Let's take this data as an example, and in this case we're going to sort it by the most losses. So with our data we could add the sort function. Our array is going to be this. Our sort index is asking us for the column index number within our array that we want to sort by. So we want to sort by 1, 2, 3, 4, 5, and then our sort order we're going to do in descending order, so we're going to put -1, and then by column we're just going to leave blank as that's within square brackets, so as a optional argument. And keep an eye on the order of these and the losses. As I press enter, you can now see we have the most losses at the top and the least losses at the bottom. Spilled dynamic arrays aren't nicely formatted, so I'll show you a little trick on how we can achieve that. We're just going to add some conditional formatting to this output. So I'm going to select the array, I'm going to go to conditional formatting on the home tab. We're going to create a new rule, we'll use a custom formula, and we'll say where this cell, take our cell lock off with F4, is greater than blank. And then our format that we're going to apply is going to be just a straight border. Click OK. And now you can see anywhere where we've got cells that aren't blank, we have lines. I'm just going to make this slightly wider so we can see. I'm just going to wrap the headings. Also, another little tip, as we're going to be using this same data set a number of times for this demo, I'm just going to give it a named range so we can quickly pick it up. If you don't know how to use named ranges, check out my other videos where I cover this topic. Highlight this range. I'm just going to call this league data. Now let's have another look at a dynamic array function. The sort function only allows us to sort by one single column index within our array. However, we can use the SORTBY function, which allows us to sort by a number of arrays, and these arrays can be within our data set or even outside of it, so internal or external. So this time, rather than cell range, we're going to use that new named range. We're going to call this league data. You can see that's picked up our data set. Now, our first array that we're going to sort by is going to be our wins column, and the sort order of that is we'll have largest to smallest, so -1, and then we're also going to sort by the number of goals for as our secondary argument, and our order is going to be -1 again on that. Now we're going to close that. So now we should have an order of most wins, and anywhere where wins are drawing, they should be sorted by the goals scored. So if we have a look at our matching wins, you can see Chelsea and Newcastle are correctly sorted on goals for. Let's test this logic. So if we go to Newcastle, we're going to give them more goals than Chelsea. So if we change this to 76, we should see Newcastle leapfrog Chelsea. And there we have it. That's updated, 76 goals versus 75. All of our data might not be together to work with in a nice dynamic array. So what we can do is we can combine data either vertically or horizontally using the VSTACK or the HSTACK. An example of a VSTACK, we start typing VSTACK, press tab, so we can stack multiple arrays. So if we just take our match day 1 results table, and then if we put comma, go to our match day 2, I'm going to select the array, not including the headers this time, close parenthesis. Now we have match week 1 and 2 data all stacked within one simple array. To illustrate the HSTACK, which is a horizontal stack, we could put this array again, our match day 1 array, take our match day 2 array, this time I'm going to include the headers, close our parenthesis for these 2 arrays, and now you can see we've got our match day 1 data here and our match day 2 data stacked by the side of it into one array. We can easily filter these arrays that we're working with for certain criteria. So if we start typing the filter function, press tab, our array, I'm going to use our league data named range, and then what do we want to include within that array? So we could say maybe where goal difference is positive, so this range is greater than 0, close our parenthesis. So now our results from this range are purely the ones that have a positive goal difference in this final column. You can work with dynamic ranges using a shortcut, and this is the hash identifier. So if I wanted to reference this existing array that we have here, I can click there and then press the hash key, and you can see by adding that hash, it's recognized this is the start of a dynamic array, this is the array size, and therefore as that array grows and shrinks, referencing it with the hash will automatically grow with it. Let's look at the sequence function, which allows us to generate a sequence of numbers. In our example here, we might want to give these teams a rank of 1 to 8. So we could start typing the sequence function, press tab. So the number of rows that we want in this example is 9. The number of columns you can see is in square brackets, so is optional. So we'll just press comma to avoid that. We're going to start at number 0 and we're going to step up in increments of 1. If we press enter there, you can see now we've got a nice ranking against the side of these teams. What about if we wanted the word rank at the top of here and the numbers to start at 1 instead of 0? Instead, what we could do is we could vertically stack the word rank in array 1, and then our second array could be the sequence of 8 rows starting at 1 and counting up. We just close parenthesis on the VSTACK, press enter. You can see now we've got our rank as our first vertically stacked array. followed by the numbers 1 to 8 below. A little bonus tip when you're sequencing with arrays, it's quite useful sometimes to count the number of columns or rows using the rows or the columns function. So here what we could do, instead of hard coding 8, is we could count the number of rows within this array, and we could use the dot operator to trim that range. If we close our rows function and press enter, you can see we get the same results as the rows is counting. There's 8 rows within our array. If this array grew by a test row, you can see also how a number of rows count grows with it. Often there'll be certain rows or columns that you don't actually want to extract from your source data array. What we can use is a number of features to actually target specific rows or columns within our data. Let's take a look. In this example, we just want the top 10 teams from the league. For this, we can use the take function, which returns a number of rows or columns from the array start or end. We're going to use our league data and the number of rows we want to take. I'm going to take 11 so that we get the top 10 teams including the headers, and I'm going to leave the columns argument blank. Now we just have the top 10 rows there. If we were to invert that number with a negative, it would work from the end of the array. So you can see we've just got the bottom 11 rows there instead. The opposite of the take is to use the drop function. In this example, we might want to take our league data but get rid of the headers. So we could drop from the league data our first row, which will give us that array without the first row. And again, similar to the take, if we were to invert the number with a negative signage, it would drop off the last row from our source data. We can take entire rows or columns if we use the CHOOSECOLS function within our league data set, and then you can see we can put in a single column number or multiples. So we might just take the first column for the team, take our second column for the games played, and our sixth column for the goals scored, and that just gives us those 3 specific columns. Similar for CHOOSEROWS within our league data set. If we just wanted the header row and maybe rows 2, 3, 4 and 5, that would give us those specific rows. These don't need to be sequential, by the way. We could have chose 1, 2, 3, 4 and 20. The array shapes can be changed. So where we've got vertical arrays here, so we can use the to-row function to change arrays to a single row. So like for example this column, we could convert to a row like that. You're probably starting to see how these dynamic array functions all work together cohesively. So here we could use a VSTACK to stack that array and have the wins below it with this array converted. So we've got two row functions within a vertical stack. And now we've got our data spliced the opposite way to how we have here. The TOCOL function does similar. So where we've got headings going across our rows here, we could change them to a column like so. With dynamic arrays, you can't use aggregators. These will change the entire spill array into one single returned value. So for example, if we wanted to sum up these columns, we couldn't do the sum of this array here, because instead of spilling horizontally across each of these columns, this is just simply going to sum that entire array into one. So instead, what we can do is the BYCOL function. I'm going to type BYCOL tab. Our array is going to be our numbers here, and the function that we want to do, pre-populated here, are called ETA LAMBDAs. Now these are built-in lambda functions for commonly used tasks. So in this particular example, we could simply use the sum ETA LAMBDA. Press enter. Now that's going to give us by column within our array the total sum. Likewise, if we wanted to sum across, we could use the BYROW function. And if we wanted to work out the total number of games played from the wins, draws or losses, we could highlight these columns, and the function again would be the sum. And now we have the games played totals matching up to our games played totals here. To illustrate how this ETA lambda is actually working and to help you write your own lambdas, I'm just going to show you how this would traditionally look with a full lambda function. We type lambda in here, and then from our BYROW function we're going to get the result of each of these rows. Now we need to define that as a parameter. We could call this R, or we could call it row, anything you like. And then we're going to do the sum of row, close our parenthesis on the sum, close our parenthesis on the lambda, and close our parenthesis on the BYROW. Now that gives us the exact same result as the ETA LAMBDA, which is just a shortcut way of getting some of those built-in simple functions. If you're new to lambda function, then please watch my video on lambdas, which will give you a deeper understanding of how these work. They're great for use with dynamic array formulas. We could make this more complex. We could say, for example, if the sum of row is greater than 38, then over 38 games played. Otherwise, under 38 games played. You can see we've got a more complex result there. We can make our arrays grow using the expand function. If we take our example from earlier where we stacked together game week 1 and 2 on top of each other, we can make this grow so that there's an area for match week 3 already, even though we don't have the data. So instead, we could wrap the expand function around our array, and the number of rows we want will be the total rows for this array. So at the moment we have 10 games per week. So 20 games plus a header is 21. So if we change this array to be 31, it's going to give us an additional 10 rows. I'm not going to add any more columns, and we're going to pad with, so this is just what those extra rows are going to say, and I'll call week 3. Close our parenthesis, press enter. You can see our array has now grown by this additional 10 rows, and within each of those cells we've padded it with the word week 3. The use of the let function with dynamic arrays can greatly improve the efficiency of your formulas. You can check out my other video dedicated to let for a deep understanding of it, but to give you an illustrative example here, instead of hard coding 31, what we could do is count the number of rows within our stacked array to add 10 on. However, to find the number of rows within that array, we'd have to repeat the VSTACK operation within this and then add on 10, which would give us the same result. However, you can see the inefficiency within this calc where we have VSTACK happening twice. So instead, what we could do is declare a let function, and we could declare our stack data as a variable that I'm just going to call data, and that is going to be the result of our VSTACK. And then we're going to get the number of rows as our rows within our data plus 10. And then our new data set is going to become expansion. So we use the expand of our original data set by the number of rows we've counted, which is our original data rows plus 10. And we're going to pad with week 3 again. And then at the end of the let, we can just call the result of that new data. Just going to delete all this old formula, close our parenthesis. You can see we have the same results there, but in a neat let where we're not repeating the vertical stack twice that we had originally. And we're also making our row count a dynamic count of our original data, which was stacked together, plus an additional 10 rows. To shape your own arrays, you can use the MAKEARRAY function. At the moment in this table we have no points for wins. So for example, if we took the games 1 and multiplied by 3 points per win, this will give us our points. However, we could use the MAKEARRAY function, the number of rows within our array. We could use the rows function to count how many rows are within this array, which should return 20. Our number of columns, we're just going to have the team names and the points. So we'll just have 2 columns, and then we need to use a lambda function. And for this lambda function, we'll receive both a row and a column. I'm just going to denote these as R and C for rows and columns. And then we're going to say if our column number equals 1, then we'll index this array. Our row number will be the argument that's passed through the lambda for R. And then we only have 1 column, so we can ignore that argument. And then our argument for false will be another index, and this time we're going to index the wins. We're going to receive the R argument from our lambda again, Again, not interested in the column argument, and we're going to times this by 3. Close parenthesis on our if, close parenthesis on our lambda, and then close parenthesis on our make array. And there we have our own make array, utilising the rows function and lambdas and index from our original larger array. The map function will allow us to create an array. Use map. So our array, we might want to choose to categorise the teams based off their number of losses. So we could use this array, and then we'd use a lambda. In that lambda, we're going to receive the number of losses from our map. So we can say L for losses, and then we can say if L is less than 10, good, otherwise bad. We close parenthesis on our if, our lambda, and our map. We now have grading based off the number of losses being above or below 10 with a custom mapped array. The scan function allows us to calculate intermediate results across an array. We have a look at that in action. We could have a cumulative total running down the side of this table for goals scored. To do that, we'd type scan. Our initial value would be 0. Our array would be this for goals for. Our function would be a lambda, and from that we'd have an accumulative result and a current row result. I'm just going to shorten those for my parameter names, and the result of that lambda would be current row plus the accumulator. Close parenthesis on our lambda and then on our scan. And that will give us a cumulative total running down the side. We could actually get to this cumulative total with one cell without seeing all the intermediate calculations along the way. To do that, we could use the reduce function. Our initial value will be 0. Our array will be the goals for again. Our function will be a lambda, and then we're going to receive a cumulative result and a current result again, and then our result will be cumulative plus current, close parenthesis on our lambda and our reduce, and there in a single cell we've got that same cumulative total that we saw step by step using our scan. There we go. In just 20 minutes I've shown you my top 20 dynamic array functions. There's plenty more, we've not covered them all. I'll be doing that in future videos. Let me know in the comments what dynamic array functions you found useful and any others that I've not covered that you'd like me to cover in future. Please remember to hit that subscribe button, it really helps the channel. Also give it a thumbs up if you enjoyed it, and I'll see you in our next video.